Hello students, in this session we will discuss fixed beam. So we will start with definition of fixed beam and then we will discuss advantages and disadvantages of fixed beam. After that we will discuss bending moment and shear force diagram of a fixed beam which is carrying central point load. After that we will solve a numerical. So let's start with definition of fixed beam. So, a beam supported on both the ends and restrained from rotation is called fixed beam. So, here in this given picture, you can see that the horizontal line represents beam, which is fixed at both the ends. This type of the beam are also known as built-in beam or constrained beam or Ancaster beam. Now, here are the advantages of fixed beam. So, the fixed beam is stiffer, stronger and more stable. The slope at both the ends is zero. The deflection at center is very much reduced. The fixing moment are developed at two ends which reduce maximum bending moment at the center of the beam. So these are the advantages of fixed beam. Now let's discuss disadvantages of fixed beam. So stresses are also developed in a beam due to change in temperature. The fixity of beam is reduced due to vibration. Both the ends of the beam must be at the same level, otherwise extra stress will develop in the beam. So these are the advantages and disadvantages of the fixed beam. Now let's discuss bending moment and shear force diagram for a fixed beam which is carrying point load. So here is a given beam AB. Total length of this beam is L and the beam carries one point load of W at point C. Now here are the steps that we will follow for solving this numerical. So in step number 1, we will assume that the fixed beam as simply supported beam and then we will draw bending moment diagram. This bending moment diagram is also called mu diagram. So in step number 1, we will draw mu diagram. In step number 2, we will draw bending moment diagram for a beam with only end moments MA and MB. It means here we assume that the fixed beam has only end moments MA and MB and there is no load in between. This bending moment diagram is known as mu dash diagram. Okay, so in step number 2, we will draw mu dash diagram. In step number 3, we will calculate end moments MA and MB by applying equation area of mu diagram plus area of mu dash diagram is equal to 0. Now in step number 4, we will draw bending moment diagram for fixed beam and then in step number 5, we will calculate shear force and then we will draw shear force diagram for a fixed beam. So let's start with step number 1. So here this is the given beam. Now in step number 1, we assume that the given fixed beam is a simply supported beam. So I have just replaced fixed support at point A and B with the simple support at point A and B. So the beam is converted into simple support beam. Now we know that at both the end of the simple support beam, moment is 0 and in a simply supported beam, maximum moment is generated at the center, which is equal to WL by 4. So here, maximum bending moment generated at point C is WL by 4 and moment at both the ends are 0. Okay. Now, this triangle represents bending moment diagram for the simply supported beam. This diagram is also known as mu diagram. Okay. Now, you know that at point B and A, there is moment is equal to 0 and at point C moment is WL by 4. Now in between point A and C and B there is no load, so bending moment diagram will be straight inclined line. Now let's move to step number 2. In step number 2 we will draw diagram for a beam with only end moments MA and MB. This diagram is known as mu dash diagram. So here you can see that this is a beam which we consider that there is no load in between and the beam has only end moments MA and MB. Now these are the bending moment diagram which is called mu dash diagram. Here MA is equal to MB. So bending moment diagram will be a simple rectangle in a shape. Okay. Now let's move to step number 3. In step number 3 we will calculate MA and MB by applying equation area of mu diagram plus area of mu dash diagram is equal to 0. So area of mu diagram is also known as or denoted by small a. And here you can see that mu diagram is triangle in a shape. And area of triangle is equal to what? 1/2 height of the triangle into base of triangle. So here in case of mu diagram, height of the triangle is WL by 4 and base of the triangle is L. So we are getting total area of mu diagram, which is small a, is equal to 1/2 into W into L by 4 into L. Say this is equation number 1. Now area of mu dash diagram, which is denoted by A dash. So here mu dash diagram is nothing but a rectangle in a shape. So area of rectangle is equal to what? Width into depth. So it will be MA into L. Say this is equation number 2. Now let's apply equation A plus A dash is equal to 0. So from equation number 1 and equation number 2 we can say that 1/2 W into L by 4 into L plus MA into L is equal to 0. Therefore, WL square by 8 plus MA into L is equal to 0. Therefore, I am getting MA is equal to minus WL by 8. So, here the value of MA is equal to minus W into L by 8. Value of MA is equal to MB. So, I am getting MB is equal to minus W into L by 8. Now let's move to step number 4. In step number 4, we will draw bending moment diagram for a fixed beam. So here this is the given fixed beam and these are the mu diagram and mu dash diagram that we discussed already. Now bending moment diagram for a fixed beam is nothing but the combination of these two diagrams, mu diagram and mu dash diagram. So here you can see that this is the bending moment diagram for a fixed beam where MA is equal to MB is equal to minus WL by 8. Okay. Now let's move to step number 5. In step number 5 we will calculate shear force and then we will draw shear force diagram. So we know that for a symmetrically loaded simply supported beam, reaction at A is equal to reaction at B is equal to total load by 2. So we can say that RA is equal to RB is equal to total load by 2. Here in our case total load of the beam is W. So RA is equal to RB is equal to W by 2. So RA and RB are the reactions at point A and point B. And from the reactions we can draw shear force diagram. So here is the shear force diagram. Okay. Now let's calculate one numerical. Here one fixed beam is given. Total length of this beam is 5 meter and beam carries 140 kilonewton load at point C. Okay. Now we are required to draw shear force and bending moment diagram for this fixed beam. Okay. So as we discussed, first of all we will start with step number 1. In step number 1 we assume that the given fixed beam is a simply supported beam. Okay. So you can see that here I replace this fixed end at point A and B with the simple end. Okay. Simple support. Okay. So here is the simply supported beam. Okay. Now I will draw bending moment diagram for this simply supported beam, which is also known as mu diagram. And for that I need to calculate maximum bending moment at point C, which is equal to WL by 4. Here in our case W is equal to 40, length is equal to 5 meter by 4. So I am getting bending moment at point C is equal to 50 kilonewton into meter. And here is the bending moment diagram for a simply supported beam which is carrying 40 kilonewton central point load. Okay. This diagram is known as mu diagram as we discussed. Now in step number 2, we will draw bending moment diagram for a beam with only end moments MA and MB. This diagram is known as mu dash diagram. So here this is a fixed beam which is carrying only end moments MA and MB. There is no load in between. Okay, and here is the bending moment diagram for the beam. Okay, this diagram is known as mu dash diagram. Now let's move to step number 3. In step number 3, we will calculate end moments MA and MB. And for that, we will apply equation area of mu dash diagram plus area of mu diagram is equal to 0. So let's calculate area of mu diagram first, which is denoted by small a. Here, area of mu diagram is triangle in a shape. So area will be equal to 1/2 into 50, which is height of the triangle, and base is 5 meter. Say this is equation number 1. Now let's calculate area of mu dash diagram, which is A dash. So it is equal to MA into 5 meter. 5 meter is a length. Okay. This represent area of this mu dash diagram. Now we know that A plus A dash is equal to 0. So from equation number 1 and equation number 2, we can say that 1/2 into 50 into 5 plus MA into 5 is equal to 0. Okay. Therefore, 125 plus MA into 5 is equal to 0. Therefore, I can say that MA is equal to minus 25 kilonewton into meter. Here, MA is equal to MB. That's why MB is also minus 25 kilonewton into meter. Now, let's move to step number 4. In step number 4, we will draw bending moment diagram for a fixed beam. And it is nothing but the combination of mu diagram and mu dash diagram. Here you can see that this is the bending moment diagram, where bending moment at C is 50 kilonewton into meter and MA and MB are 25 kilonewton into meter. Now in step number 5, we will draw shear force diagram, but before drawing shear force diagram, first of all we will calculate shear force. Okay, and for that we need to calculate reactions RA and RB. So reaction RA is equal to RB is equal to total load by 2. Here total load is 40. So 40 by 2 I am getting RA is equal to RB is equal to 20. Now here is the shear force diagram. So at point A, shear force is 20. Okay, so it is positive. So at point A, I mentioned positive shear force. Now at point C, shear force will be 20 minus 40, which is minus 20. Okay, now in between point A and C, there is no load. So shear force line will be horizontal line. Okay, now shear force at point B is equal to minus 20 as there is no load in between point C to B. So here in between point C to B, shear force line will be straight horizontal line. So we have draw bending moment and shear force diagram for the given fixed beam. This is end of the session. Now in next session we will discuss fixed beam which is carrying UDL.